Okay, so kind of the way they set this up is kind of nice. They say we've learned a lot this year about solving equations, inverses, one-to-one functions, exponents, logarithms, and their properties. So today we're going to put this all together. So the first equation we're going to solve, though, isn't a first year of algebra equation, but it's kind of a warm-up because we apply the same principles. And it's kind of ironic. This is exactly the types of equations we were just doing in my Algebra 1 class. So it's kind of fun. So if I'm supposed to solve an equation like this, right? Okay, the first thing I'm going to do is put together my like terms, right? So I would end up on this side, I'd have a 2x squared minus 5. Okay, and again, anytime we're solving, even if they don't help you by saying solve for x, if it says solve, you're trying to get the x by itself. Okay, so getting that x by itself, I add 5 to both sides. Now I've got 2x squared equals 32. I divide both sides by 2. X squared equals 16. Remembering when we did trig functions where you needed to take the square root, so you're hearing that alarm, right? When you go to do this, ding, 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 ding. Don't forget the plus minus, right? So x equals plus minus 4. And the great thing about solving any equation, you could always drop the numbers back in to the original equation and verify that it is a true statement, whether or not I put in x equals -4 or 4, because those x squareds turn into positive 16, right? So far, so good? Okay. So now, for whatever reason, I think it's okay. They decided to say, fill in the question marks. It's kind of like solving for x, but it's sort of a friendly way maybe to introduce this. So if I said 3 to the something equals 81, you would be able to tell me that 3 to the woo. Okay. And again, we know 9 times 9 is 81. Each 9 is a 3 times 3, right? So 3 to the 4th. Okay, so if it says log base 17 of something equals 0, okay, personally, I think it's easier to switch it to the exponential. And again, because I did this at first period, I'm kind of already warmed up, right? I think logs are kind of hard. So if you're not warmed up with them, I think it really helps to just kind of say, okay, logs are that if I take an exponential like 2 cubed equals 8, that means log base 2 of 8 equals 3. Remember, the log is always saying, what's the exponent? I raise the base to. So I think something like this, it's kind of easier if you switch it to, okay, my base is 17 and my exponent is 0, right? Because now this is super friendly. What's 17 to the 0 power? Okay, so that means my question mark was 1, right? You ask the log question, no matter what the base is, of 1, and you're going to get the answer is going to be 0, right? So now, again, like something like it looks, I think it looks a little intimidating written as a log, but if you switch it to an exponential and you say, here's my base, 36, here's my exponent, 1/2. Okay, that's just saying, what's the square root of 36? Okay, beautiful. So in this case, the question mark is 6, right? Log base 36 of 6 is 1/2. Then this one, I'm saying, okay, so, and this one we know doesn't work out evenly, right? Because 4 squared is 16. 4 cubed is 64. So I look at this and it's like, okay, this is not going to work out evenly. But I could write it like I could say, okay, this is really saying, okay, log base 4 of 27 equals, like if I wanted to get the exponent by itself, and then I could put it in my calculator, right? So then I could say, I could use my math button and come down here and say log base 4 of 27 And I'd be like, okay, that answer makes sense, right? Because I knew it had to be a number between 2 and 3. Okay, so it's approximately 2.377. And that makes sense, right? 4 to the 2.377 is going to equal about 27. Okay. Yeah, you are going to want your calculator handy, and it's okay to borrow one of these because sometimes it just kind of helps to look at it on the calculator. Okay. What they say next is they say rewrite each. I rewrote them up here because I think it's sometimes the easiest way to explain a log expression is rewriting it as an exponential. But if we rewrite each, this is just, if I rewrite this one, it's saying log base 3 of 81, right? And so it's kind of, it gets the thing you're solving for, the question mark by itself, right? So sometimes the exponential form will make it easier to see, sometimes the log form. This was in the log form, so I think it was a lot easier to see, right, when you wrote it like this. Okay, similarly, if I wrote 36 to the 1/2 equals question. So I'm rewriting it so that it's kind of easy to get the question mark by itself. Okay, and the same thing if I write this. Any questions or all good? Okay. So, and it says, why does rewriting the equation in alternate form help you figure out what the question mark is? I would say because it helps you isolate the variable, right? And then also, it also helps because you can confirm your answer makes sense. Because I don't know, for me, it's just easier when I'm glancing at an exponential to tell it makes sense. You know, so something like this, when you go, oh yeah, that makes sense because 4 squared is 16 and 4 cubed is 64. I think it, again, maybe some people, it's effortless for them to look at the log and know it's correct. So now we're going to have to do a little bit more work to isolate the question mark. Okay. So what if it's slightly more buried? Okay. Kind of thinking of that first question. So here, I'm just going to add 4 to both sides. And now this is a good example of one where you have to be a little bit careful. Because am I the only person that when I see a base 3 and a 9, like I might think it's, oh, is it 2? Because 3 squared is, maybe I'm the only one, but it's not, because this is saying log base 3 of something equals 9. So it's actually saying 3 to the 9th equals that question mark. So if you put it in your calculator, this is actually a pretty big number, right? 3 to the 9th is 19,683. Okay. Right. So log base 3 of 19,683 will equal 9. Okay. So we're good with that. So it's then this one, okay, this is actually saying 5 times 2 to the 7th minus question mark. So I don't think you should put in x's, because then x's will, at least in pre-calc, tend to be a variable, right? We don't tend to use x's for multiplication, but I think it really helps sometimes to put those dots in, right? Because then it's kind of easier for me to say, you know what, I'm going to get this 2 to the something by itself, and I can do that by dividing by 5. I think it's easier if you put the little dot there to remind yourself that, okay, I'm good. So I've got 2 to the 7 minus question mark equals 8. Okay, what am I going to do to the 8 so that this is easier to to figure out? How can I rewrite my 8? 2 cubed, right? Because then I'd have 2 to the 7 minus something equals 2 cubed. If they match, if the bases match and they're equal, now I get to just pull out that exponent part, right? So then it's like super friendly, right? 7 minus something equals 3. Okay, we're all good that the something has to be 4. Okay, so if you're able to kind of manipulate the expression, right, so that the bases are the same and it's equal, then you get to just look at the exponent piece. Okay, so the same thing. The first thing I'm going to do is rewrite my ln as log base e, because I think it makes it friendlier. Okay, and so this is saying that e raised to the 0 power is going to equal the square root of something minus 8. Okay, so that maybe I'm wrong, but I think that was a little bit the hard part. Now we're kind of home free, right? Because what's e to the 0 power going to be? 1. Okay, so I know that I want this question mark minus 8 to be 1. And the square root of 1 is 1. Exactly. So this question mark has got to be 9, right? And you can check it, right? 1 does equal the square root of 9 minus 8. Feeling good? Okay. So again, even though it kind of looked maybe a little intimidating, right? Like each little step are things that we've done before. Okay, so, and the same thing here, it's just practicing with this idea that if the base is the same, all I have to do is just look at the exponents, right? So for this one, the question mark has to equal 11, right? Because 4 to the 11th equals 4 to the 11th. We don't even need to worry about, wow, 4 to the 11th is going to be a really big number. You don't even need to worry about that. If you're just solving for question mark, right? It's that the question mark equals 11. So here, the same sort of thing. Okay, the base is 5 and they're equal. I don't even have to worry about that base 5. And so I know that 3 times question mark minus 1 equals 20, right? 3 times question mark equals 21. We are all good that the question mark has to be 7, right? And you can put it in and double check. 3 times 7 is 21 minus 1, okay? So this is, again, just practicing this idea. Okay, they're equal, same base, question mark has to be 10, right? And so it's easy to get kind of derailed by thinking, oh, I don't know what log base 4 of 10 is. Okay, you would need your calculator to estimate it, right? Because 4 to the first power is 4, and 4 squared is 16. So the only part you would need to be able to say is, oh, I know that's a number between 1 and 2, right? And I could either get closer by kind of saying, kind of practicing, kind of like do some guess and check, or just put it in your calculator. Okay, so now this next one, we are going to use our log properties because I would like this one to look more like this, right? So you could just focus on not the log part. So they're both log base 7. I can only do that log property if it's the same base. So if I'm going to rewrite this as log base 7 of 20 equals log base 7 of question mark divided by 2, right? We're using the log property on page 11. So same base subtraction. I can rewrite this as a quotient. Now, I don't even have to worry about the log base 7 part. I get to say 20 equals something divided by 2. Okay, so we're all good that the something has to be 40. Okay, very intimidating looking initially, but each little step is not that bad, especially, okay, what divided by 2 equals 20? That would be 40. Okay, Any questions so far? So far, so good? Okay. So now, okay, combine everything you know about exponents, logarithms, and solving equations to figure out what x is. Okay, so step one, let's use those log properties because I am changing this subtraction into a quotient. So the natural log of x plus 6 divided by x has to equal the natural log of x. Yeah, Grayson. Pardon? Yeah, totally. That's fine. So, yeah, you could put it in your calculator, would be a way to do it. Yeah. Yeah. Yeah, you could do it that way. You could add the natural log to both sides too. So then you'd have 2 times the natural log. So yeah, you could rewrite it so you'd have this. Like this is maybe an easier way to do it. Right? Something like that. You could do it that way. Okay. So no matter what, you get to drop, right? So at this point, you'd have x plus 6 equals x squared, right? And the same thing here, I've got x plus 6 over x equals x. So I multiply both sides by x. Okay, either way, we get to this point, right? So we've got x plus 6 equals x squared, no matter how you did it. So now I am just going to factor, right? Okay, to find the answer to that quadratic. Okay, so now, so the two x's are 3 and -2, but we have a problem. One of these does not work, right? One of them is extraneous. So which one doesn't work and why? Great. Exactly, because we cannot take the log any base of 0 or negative numbers. So you see up here, if you tried to put this -2, it would like blow the whole thing up, right? I cannot. It's undefined. I cannot take the natural log of -2. So at this point, I cross that out. That is extraneous, right? Because this is going to happen sometimes where you're going to get a solution that you need to exclude. Okay, so the answer is 3, and then you can drop it in and it works, right? That'll be the natural log of 9 minus the natural log of 3 equals the natural log of 3. Okay, and it makes sense. You could use the log property to say, oh yeah, natural log of 3 equals, or you could put it in your calculator to make sure it works. Okay, so so that's a good point that there are a lot of these, like just like solving an algebra equation, right? Our work could look different in the middle, right? But we should all end up with that x equals 3. Okay, any questions on page 12? Okay, so that means we are good to go to the box at the top of page 13 to put in our important ideas. And our important ideas are strategies. Okay, so these are strategies for solving equations with either exponentials. And I think these are a little bit, did you have a question? Are we good? Okay, so I think these are a little bit difficult because as opposed to some of the other things we've done, like you always kind of solve some things the same way. When it looks like this, I do this and then this, you know, this is a little bit, these are a little bit harder because sometimes they're exponential and sometimes they're logs, and you have to do kind of different steps to solve them. And so these are kind of the tools in your toolkit or some of the things you're going to do to solve these. So the first one, you could say you're going to apply your log properties. And again, depending on the situation, we don't say you're going to condense or you're going to expand. We just say you're going to apply the log properties. Because on like the ones we were doing, you wanted to condense, but there could be a situation where it'll help you by using the expand direction. You are going to want to use inverse operations, right? Because again, to get the x by itself. So, and here, kind of the inverse of a log is an exponential. Inverse of an exponential is a log. You are sometimes going to want to rewrite in the alternate form, okay, to isolate the variable. And what I mean by that is kind of if we have something like if log base 2 of something equals 3, it's a lot easier to say 2 cubed equals something, isn't it? I just think that's a lot easier. Okay. I'll put that in parentheses as an example. And then there's a name for that situation that we are looking at here, right? Where it's like, oh, I don't even have to worry about the base of 4, right? Because the same base and they were equal, or the same base log and they were equal. What we call that is the one-to-one property. Okay, and what that means is if I've got b to the x equals b to the y, I do not even need to worry about what that base is. I can just say, oh, then x equals y, right? And similarly, if I've got log base b of x equals log base b of y, I don't even have to worry about the log part anymore. I know that x equals y. So a lot of times you're able to make one of these a lot easier if you can get it rewritten in that same base. Like that one where we, just by switching the 8 to 2 cubed, it made it much, much easier. And then you may use kind of the calculator to solve or check. So obviously in certain situations, there will be a no calculator. So then it's perfectly okay to leave your answer in the somewhat ugly log base 4 of 27, right? I mean, because sometimes you just need to do these without a calculator. And that's a perfectly acceptable answer. Log base 4 of 27. You could put it in your calculator and get a decimal approximation. So again, depending on the situation, like if you're doing an assignment where you're supposed to solve the equations, and you can get the answer, but then you can use your calculator to verify that you've done it correctly. Okay, so let's do some of these, okay? So, and again, they're individually, like they're not that hard, but what's hard is they all look different, right? So something like this, log base 49 of x equals 1/2. So I think the easiest way to do it is, okay, this is my base. This is my exponent. And now it's not hard, right? 49 to the 1/2 power means the square root of 49, which is 7. Okay, so x equals 7. And you can check and go, oh yeah, that makes sense. Log base 49 of 7 equals 1/2. Now this looks intimidating, I think. 6 to the x plus 10 equals 46. But if you just say, okay, I'm just going to get the x by itself, right? So the first thing I'm going to do, I'm just going to subtract 10 from both sides. Okay, now I have the super friendly 6 to the what equals 36, right? Just by subtracting the 10 from both sides, now it's super friendly. 6 to the what power equals 36? 2, right? 6 squared is 36. Okay, so, I mean, at this point, you could say log base 6 of 36 equals what? But I think this one's friendly enough that for most people, it's kind of easier to say 6 to the what power equals 36, right? But again, you could rewrite it. Log base 6 of 36, right? And it's totally okay to do. Okay, so this next one, again, it looks kind of hard. It's got E, it's got a 2-term exponent, but we'll just persevere. We've got this, right? So the first thing we do is we're just going to subtract 5. Okay, it looks so much better already. E to the x plus 1 equals 15. Okay, so this, like just kind of algebra rules, as long as I do the same thing to both sides, should be good. Because what I want to do on this side is if I said log base E, that side would just be x plus 1, right? So that's why I'm going to do the natural log of both sides, okay? Because it's going to really help, especially on this side. So I'm going to write here, I am taking the natural log of both sides. ln. So I'm going to say ln, and this means, right, log base E. That is interchangeable, ln log base E. But again, you don't have to. I think it makes it kind of easier to see if you're not sure what's happening here. I get to take the x plus 1, right? That this side is just going to be x plus 1. Okay, so did that make sense? The reason I did that is now it's like it unlocked that x that was stuck up there in the exponent by taking the natural log. It was able to just be x plus 1. Meanwhile, on this other side, that's okay. I mean, like it's something that I need my calculator to approximate maybe, but at the same time, okay, I know that E squared is about 7.4, right? So, and then, so this is going to be, probably something between, let's say 2 and 3. Okay, so this is, but you can just write natural log of 15. So all I have to do to get the x by itself, right, is subtract 1. So the x equals the natural log of 15 minus 1. So that's an exact answer, but I can figure out, right, I can do this in my calculator to get a decimal approximation. So I use my ln button, right, down here, ln of 15, natural log of 15. Oh, yeah, that makes sense. It's about 2.7, right? I was pretty sure it was going to be right between 2 and 3. And then I subtract 1, okay? And I get about 1.708. And I can just like kind of confirm this is correct, right? If I put it back in, if I say plus 1, and then I say, if I raise E to that power, I get 15, right? 15 plus 5 is 20, okay? So again, you don't have to, but sometimes it just makes you feel more confident, by putting this back in your calculator and saying, oh, that works beautifully. Okay, so this next part, we're going to use that one-to-one property. And so here, I'm going to say, okay, same base, right? ln, you don't need to rewrite it as log base E, but just, I was surprised. A couple of people asked me questions yesterday that made me realize it was not effortless to be kind of visualizing that. ln means log base E. Same base. So I do not have to even worry about the log part. I get to just say, oh, when does 2x minus 2 equal 11? When does 2x equal 13? Right? The answer is just going to be x equals 13 halves. Okay? This next one, it's like, oh, it'd be a lot easier if they had the same base. And again, I get to rewrite my 8 as 2 cubed. So I'm going to say 2 to the x squared minus 6 equals 2 cubed. So now I get to just take out these exponents and say, when does x squared minus 6 equal 3? When does x squared equal 9? So the x is going to be plus or minus 3. Okay, and then it's got, this is a friendly one. It's like you can just in your head drop that back in, right? 2 to the 3 squared minus 6, okay, is going to be 2 cubed. Any questions? Okay, going okay? Beautiful. Okay, so now we're going to solve for x. And when I see a subtraction and the same base, hopefully it makes sense. I am going to want to use my log properties, because if I could rearrange this thing so that it was log base 4 of just a single expression equals 1, I'm going to be able to then say 4 to the 1 equals whatever that is. Okay, so my first step is like to say, you know what, I am going to take this coefficient and write it as an exponent. So I'm going to have log base 4 of x squared minus log base 4 of x cubed equals 1. Okay, same base, subtraction. I get to write this as a quotient. Okay, so it's going to be log base 4 of x squared divided by x cubed equals 1. It is okay for me to simplify this, right? X squared divided by x cubed can be simplified. So it's log base 4 of 1 over x, right? We had an x squared that we could cancel out, equals 1. At this point, I am switching it to an exponential because I think it's a lot easier to see it if I say, this is my base 4, this is my exponent 1 equals 1 over x. So it's just 4 equals 1 over x. So now I just have to solve for x, right? 4x equals 1. Okay. So we're good with, and again, you can just drop it in to make sure it works. Okay, now we're going to use our graphing calculator to solve for this one. So the way you can do this, the easiest way is just say, I'm going to put in this function, y1 equals 6 times e to the 1 minus x. And then my second function is just going to be this horizontal line. And so when do these cross, right? Okay, so everyone's good with, and you can borrow a calculator if you want. These are the two functions you're going to put in your calculator. And this is one, you can even graph that one by hand, right? It's got a vertical stretch of 6. I would probably rewrite this as negative x plus 1, right? So then it's flipping it around, right? And shifting it over. Okay, because my horizontal line is at 25, your default window is not going to go tall enough. Okay, so do me a favor, do this on your calculator, right? If you didn't already change your window to match something like mine, you want your y to be, you need your y max bigger than 25, right? Yeah, so definitely borrow a calculator, right? You want to do this on a calculator. Okay, so, okay, because you need to be able to see where these cross, okay? So you've got something like this. And okay, and a couple people in first period didn't get this picture. So if you're not getting this picture, I am happy to take a look at your calculator. Yeah, sure. So my window is the main thing from your default window, like the default window, I think the y max is 10. Since we're putting a horizontal line at y equals 25, most people, if they don't adjust their window, might miss that if they have the default window. Okay, so we've adjusted our window. We see the two lines crossing, okay? And so kind of, we've done intersections before. I'm gonna do a little recap of the, calculator keystrokes, right? I need to find the intersection of that red and blue function. So the way I do that is I say second, calculate, and I choose choice 5, intersection. Okay, and it seems the reason the calculator needs to ask you 3 questions is because remember all those times we did this with the sine and the cosine functions, like the daylight, when is there 15 hours of daylight or 13 hours of daylight? and that was a periodic function. So we saw a whole bunch of intersections. Your calculator is set up, even for this one, there's only one intersection, but it still asks you the question the same way. So it says, hey, which is the first curve you care about? And you're like, of course it is that blue one. And they say, is this red one the second curve you care about? And you say, yes. And there's only one intersection. And so for my guess, that's the one I want. So you get negative 0.427, right? Okay. So I'm going to do it again. Okay. So it seems a little cumbersome, but the reason your calculator asks you 3 questions is because remember all those times we had the sine and cosine functions and we were seeing multiple intersections. Also, I could have like, 5 or more functions in here, and I need to tell the calculator which intersection I care about. So the way I tell the calculator, I say second, calculate, and I say, I want to find the intersection. So I come down there, and then your calculator is saying first curve. And it seems silly because I only have 2 curves or 2 functions shown, but I will comply and say the blue one. And it says second curve, and you're like, yes, the red one. And then it says guess. And the thing is, the guess, it makes more sense if we're looking at a picture that's showing multiple intersections. But it's very obvious that that's the intersection I care about. And so it comes back and says, that's the one you wanted when the x is negative 0.427. Okay, so feeling good about that. And I have to say that if you ever forget these keystrokes, there are really awesome YouTube videos for just about anything you'd want to do with the graphing calculator. So that's always available too. One thing, sometimes I kind of like to make, when it's a solve with the calculator, I kind of like to make a little sketch, kind of what it looked like. Right, so my x equals negative 0.427. And I think it's important to say, you could solve this equation, right? I don't need to do this with a calculator. I could write out, when does 6 times e to the 1 minus x equal 25, right? And I could divide both sides by 6. Now I'd have e to the 1 minus x equals 25 over 6. So what am I going to do to both sides now? Exactly. I take the natural log of both sides, and now I've got 1 minus x equals the natural log of 25/6. So if I add x to both sides and I subtract the natural log of 25/6, I'll have 1 minus the natural log of 25 over 6 equals x. And so you could definitely do it this way too, right? And then so I'd have 1 minus the natural log of 25 divided by 6. Okay, and luckily it comes out to the same thing. So again, you can do these multiple ways, and I think it's just, then you kind of feel confident, especially if you saw it a different way. You're like, I could have done that an easier way, right? So it's just nice to go through that. Okay, so if I take a look at this, and we're going to use, remember that continuous compounding, and they're saying, how long does it take $1,500, which is my principal, to triple in value? So it requires you to say, what's 3 times 1,500, right? When is it going to equal $4,500? Okay. And it's 12% interest. So that means my R is 0.12. Okay, so if I take this information, okay, and I am supposed to solve for t, okay? I did that kind of fast, but again, it should make sense, right? We've used this before, the continuous compounding. I start with 1,500, tripling it would take it to 4,500, and my interest rate is 0.12, and my job is to figure out how long will it take. Okay, so the first thing I want to do is get the E by itself, right? And you don't have to, but I think it does help to, if you put those dots and just remind yourself, that that just means 1500 times e to the 0.12 times t. Because the first thing I'm going to do is divide these both sides by 1500. No, it's 12% interest. Remember how you moved the decimal, like 3% interest is 0.03. So 12% interest is 0.12. Okay. So it's 0.12 times t. Okay, so I've got e to the 0.12 times t. Now I take the natural log of both sides. So the natural log of 3 equals 0.12 times t. So I divide both sides by 0.12. So my time, so like if you were doing a no calculator, assessment on this, you would stop there, right? Because that. Luckily, we are able to use our calculator and change that. We have not finished making the Unit 8 assessment yet. So we're not taking that till next Thursday, but we'll let you know. I think we haven't finished writing it yet, so it kind of depends. Okay. So natural log of 3 divided by 0.12. Okay, so that means 9.155 years. I don't know, that seemed to me kind of surprisingly short. I'm like, I gotta find an account that gives me 12% interest, right? It's not really, that's a very high interest rate currently. So, okay. Any questions on that? Okay, the next problem was that we're going to do. I want to do like the first problem of the assignment because it's one that's kind of hard, and I didn't want people to feel kind of stuck on it. Okay, so what we're going to do. So why don't you get out a piece of paper to start the assignment. So this is the 8-7 assignment. Okay, and we're going to do the first problem together. Okay. Okay, so the first problem, you've got the 8-7 assignment. It's going to be problems on page 311. Okay, and we are starting out with problem 42. Because this is a really good problem, but it might have been like a little intimidating if you just came upon this problem. Okay, because why this problem looks intimidating is I have different bases, right? Like everything else we've done to this point have had the same base. So the thing is, if you've got something like this, you could take the natural log of both sides. And I think like if you just randomly showed people this problem, if you took it to like, I don't know, a tutor or something, you said, hey, how am I supposed to do this problem? I think most people would say, hey, let's take the natural log of both sides. The reason is that lets me pull those x's out of the exponents and they come down to be coefficients. And it's not hard to get the x by itself. But I would say, let's maybe do it log base 2. Because I mean, you could do it that way too. And I think it actually then is more comparable to other things we've done. So, or you could take log base 2 of both sides. I just think it really cleans up the left side, right? If I do log base 2 of that side, it's just going to be just plain x plus 1. So we're going to do it this way. But it's a perfect example. This is, I think if you asked most people, which way would you do it? Most people would probably take the natural log of both sides. Okay, so that why I did it this way, this side is just going to be x plus 1. So that is pretty friendly. Now on this side, the whole reason these logs are powerful is it lets me kind of unlocks the exponent. This gets to come down. So now I'm going to have 1 minus 2x times log base 2 of 5. Okay, I can see it would be kind of almost easier if at this point we switched to a decimal approximation for this, but we're not going to because we're going to leave it in this exact form. But I think it helps to right at this point say, you know what, that's just a number. And actually it's a number that's just a little bigger than 2, right? Because 2 squared would be 4. So if I say log base 2 of 5, I can just like, okay, that's some number. It's a little bigger than 2. But I'm going to leave it in its exact form and solve for x. And right now I have the somewhat troubling problem that I've got x's on both sides, right? So I need to get my x's on the same side and get all the numbers on the other. And remembering this is just a number, the first thing I'm going to do is I'm going to distribute that kind of ugly number. So now I've got x plus 1 equals log base 2 of 5, right, times the 1, minus 2 times x times log base 2 of 5. You don't need to add those little dots, but I think it helps people remember all we're doing is multiplying this, right? It's just 2 times x times log base 2 of 5. And so now I'm going to get the x's on the same side of my equation, right? If I add to both sides this, right? Now I'll have the 2 x's on the same side. And I'm also going to subtract the 1 from both sides. So now I've got x plus 2x log base 2 of 5 on my left-hand side. And on the right-hand side, I've got log base 2 of 5 minus 1. Okay, except for the fact that log base 2 of 5 is kind of a weird looking ugly number, the algebra of this should feel really straightforward. I can get the x by itself by factoring it out, right? If I factor it out like a GCF, it's all by itself. So I'm going to, super important step here, factor out the x, right? I finally will have the x by itself. Okay, so now x is all by itself. So all I have to do is divide both sides by 1 plus 2 log base 2 of 5. Okay, so the exact way to write my answer is, okay, it's log base 2 of 5 minus 1 over 1 plus 2 times log base 2 of 5. And you're correct, the people are saying, hey, we can rewrite this as log base 2 of 25. Yeah, you could. I mean, you could write this in different ways, but at this point, we're just going to go ahead and put this in our calculator, okay, to find out what it approximately equals. Okay, so let's do this. So I'm going to press my math button and go down to log base 2 of 5. Okay, and like we knew, oh yeah, it's a number just a little bigger than 2, right? And I'm going to subtract 1. Okay, that is my numerator, log base 2 of 5 minus 1. So I'm going to divide that by 1 plus 2 times log base 2 of 5. And I get that my answer comes out to be approximately 0.234. there's a lot of ways you can check this is right. I think kind of one of the kind of fun ways to do is, why don't I store this value and then try it out right back in my original. So if I store this, I'm going to say, I'm going to store that value. I just F. I could have called it J or anything. But now if I write this 2 to the F plus 1, right? I get 2.35. So let's see what I get when I say 5 to the 1 minus 2 times. And so you can see, yay, okay, I get the same thing. Also, we could actually do this also on our calculators, right? So if I put into my calculator 2 to the x plus 1 and 5 to the 1 minus 2x, and said, I'm just going to see where these two functions intersect, right? I'm just going to graph it, and you'll get a picture like this. And then you're going to be like, oh, okay, I'm just going to figure out the x at that intersection, right? So you say, again, second calculate. I am going to go down to my choice for intersection. And then I have to do the same steps, right? Where it's like, oh, that's my first curve. Then that's my second curve. And then my guess, I'm very close to my guess. And it comes back, right? So I just wanted to show you there's like more than one correct way to do this. And especially if you have the calculator available, then there's really a lot of ways to do this. So we've done the first problem of the assignment. Okay, so now if we just go ahead and look at the assignment, it's very friendly. There's only 8 more problems, and they're all a lot easier than that example. Okay, so it's problems. So looking at this, like 17, right? So if I see log of x plus log of x plus 15 equals 2, right? First thing I'm going to do is I'm going to write that as log of x times x plus 15, right? And I'm going to remember plain log means base 10. Okay, so there's just 8 more of these problems to do for the assignment.